and good day, geometry. We are kicking off the kicking off the unit with CO33 using ratios to find angles and sides of triangles. This whole unit is going to be on triangle proportionality. 2 units ago, we focused on triangle similarity. No, that's what this is. Triangle congruency. And that's where we had side, 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 angle, side, angle, HL, and all those sorts of things. This is going to focus on triangles that are similar, or triangles are proportional things. And if you remember back to when we talked about proportionality in pre-algebra, which I guess would have been your 6th grade year, you probably talked about ratios. Okay, who remembers what a ratio compares? What a ratio compares? Lexi.
Something, it's like a 2-to-1 ratio.
Yes. Okay, so it compares. An example would be like a 2-to-1 ratio. Okay. And those the 2 and the 1, we define a fraction as being a part compared to a whole. Like 30 out of 33 would be the part of the test you got correct over the total number of points on the test. So a fraction compares a part to a whole. What does a ratio compare? What? Not whole to part. Not part to whole. Part to part. Okay? A ratio compares a part to a part. Okay? A part to a part. And I don't remember what I meant to put there in the think line. Maybe. Yeah, I don't know. I don't know what's supposed to go there. I don't quite remember what that is there for. So
It's probably for like the
You're gonna
ratio,
watch
like
the video.
maybe
Maybe
go back.
it's
Yeah, I don't know. Well, you can tell this sheet is at least 2 years old because the first question talked about the Vikings. They still play 16 games. Of course, now they play 17 games. But let's pretend they played 16 still, and the record was 12-4. The ratio of wins to losses. Okay, so what a ratio does, how many games do they play total? 16, right? So the ratio, a win-loss record, compares the part that they won versus the part that they lost. Okay, you can calculate the whole by adding them together because the 2 parts will sum to equal the whole. But the ratio itself compares the wins to the losses, 12-4. Who remembers what we use to show a ratio? What are some things that could go in between the 12 and the 4 to show that? Yeah, Lisa.
2 dots.
Could be a colon. Okay, 12-4. What else could it be? Kylie.
Just the word 2.
The word 2. 12-4. Okay, Jack.
Fraction.
Could be a fraction. This one you got to be careful with, right? Because a fraction is a part to a whole. And a ratio can be written in fraction form, but it's not actually a fraction, 12/4, right? It's meant to represent the ratio 12-4. Where you see this most often would be in slope, the rise over the run, right? Ratio of rise to run. But outside of that, there's really not a lot of applications for a fraction to work. So we will primarily use one of those 2 options, okay? And who remembers how to simplify a ratio? Our given ratio of 12-4, how do we simplify? Damien?
You divide by the other one?
Kind of. In this case, that's what you would do, but that wouldn't be the case for every situation. Beckman? Divide by the greatest common factor. Just like a fraction, right? You treat a ratio and simplifying it like you would a fraction. In this case, because 4 goes into 12, we end up dividing both by 4 and we get 3-1. But basically that means that for every 3 games they won, they lost 1. Right? For every 4 games they played, they won 3 and they lost 1. Okay? Is the light bulb flickering? Back to ratios. Okay. Kind of our introduction to proportionality here. Next question. A recipe calls for 15 cups of flour and 35 cups of sugar. What is the ratio of flour to sugar? The order matters here. If it asks for the ratio of flour to sugar, make sure you put it in flour to sugar order. So the 15 would have to come first, and the 35 would have to come second. And what would this simplify to be? What's our scale factor that we would divide by? Anthony?
3 to 5.
Divide by 5,
Yeah.
which would give us 3 to
7.
7, right? Those that bake, you probably deal with ratios pretty often, especially if you double a recipe, triple a recipe, right? You have to make sure you increase every ingredient by the same scale factor. Otherwise, it's going to taste different, right? If you only decreased the flour by a scale factor of 5, but kept the sugar the same, it's going to be really sweet, okay? If you only decrease the sugar and kept the flour the same, it's going to be not taste very good, right? So baking is a very good application of ratios. In a class of 27, the ratio of boys to girls is 2 to 1. How many boys and how many girls are in the class? Okay, so a little bit different question here, right? You're given the ratio, obviously in simplistic form, and you're also given the whole, 27 kids in the class. How would you work with this information to figure out how many boys and girls are actually in the class? Bryn?
You divide 27 by 3 because you know that there's like 3 parts of it.
Okay.
Just like with the triangle.
Just like what?
Triangle.
Oh, we did last.
Yes, when we did triangles, the inequality theorem, I think. Yeah, Bryn's saying, this 2 to 1 ratio represents 3 people, right? 2 boys and 1 girl. Okay, so now the question is, well, how many times does 3 go into 27? How many groups of 2 to 1 can we fit into 27? And that's where she said you're going to divide 27 by 3 to get that scale factor of 9. Another way to think about it is, what do I have to multiply 3 by to get to 27? You multiply by 9. Yes?
Then you multiply the 9 by 2, so the ratio is 18 to 9.
Excellent. Since you multiplied that 3 by 9 to get to 27, you would also have to multiply each part by 9 as well. And that gives us 18 to 9, which is the original ratio, right? It's equal to 2 to 1, or equivalent, I should say. They add to be 27, so the 2 parts add to be the whole. There are 18 boys and 9 girls in the class. Is this a nice way to start off the unit? Yeah? A little bit of familiarity, and if not, then, hopefully you're catching up.
Can you go through it one more
Yeah. So we're given the simplified ratio, right, which I wrote here. Okay. I then said, what's the total in that 2 to 1 ratio? The total's 3. And with that, we're looking for how do we get from 3 to 27? Because that answer represents our scale factor. So Bryn said divide 27 by 3 to get 9. Another way to think about it, what do I have to multiply by to get 27? Really the same thing, because multiplication and division are opposites. But once we figure out our scale factor is 9, we're going to multiply both parts of the original ratio by 9 to get up to 18 to 9, which is the boys and girls. Okay. In a pet store, there are a total of 60 dogs and cats in a ratio of 13 to 7. Very similar to what we just did. In a bag of 150 marbles, the ratio of red, blue, and white marbles is 6 to 11 to 8. How many red, blue, and white marbles are in the bag? Again, very similar to what we just did. Even though we have 3 parts to the ratio, your thought process is the same. How many marbles are we talking about here with 6, 11, and 8? And then what's that scale factor? Ratios are all about scale factor here. Then we get to the geometric application. That's right. That first page was kind of, this is just what a ratio is, how to use it. When we talk about, and where we're headed, we're talking about proportional similar figures, primarily in triangles. It says the ratio of angles in a triangle is 28 to 19 to 43. What are the angle measures of the triangle?
28, 29.
Now, we're given the ratio clearly in simplest form because there's no grayscale factor between 28, 19, and 43. But what's the whole?
180.
Thus, why it's important to remember the triangle sum theorem, and that every triangle is exactly 180 degrees in it, right? 28 to 19 to 43, how many degrees are there total in this base ratio? Sophie? Sorry? 90. Okay? A triangle cannot have 90 degrees. A triangle must have exactly 180 degrees, right? So what do we have to do?
Double them all.
Double them all, right? our scale factor to get to 180, get to our whole, we have to multiply by 2. Or take 180, which we know the whole is, divide by 90 to get the 2 that way. That represents our scale factor. So now we double every part of our ratio. 56 degrees, 38 degrees, and 86 degrees, which I think it is in here right now. Right? And those are the actual measurements of the triangle. Okay? The ratio of angles in triangles is 3 to 6 to 11, where the angle measures of the triangle. Very similar process. And then we get down to triangle sides, where since there is no standard sum that triangle sides have to add to, yet I need to give you the whole here. A triangle's perimeter is 72. Its sides are in a ratio of 1 to 4 to 4. What are the lengths? The ratio of triangles, angles, and sides is 8 to 11 to 11. Its perimeter is 570. What are the measures of its angles and the length of its sides? So it's basically a 2-for-1 question there. And woo, that's it. Wow. Anything we need to talk about? No?
The next one.
Which one?
The 3, 6, and 11.
That's easy.
So what we did in the one before it, I mean, this is the exact same question except it has changed the numbers here, right? So what we did here was we found how many angles or how many degrees are represented with 28, 19, and 43. That was 90, right? And then what do we do from there?
Oh, I got it. Never mind.
Okay. Which would you rather have? Homework from the book or no homework from the book?
No.
That was a trick question. Your homework.
I feel like you're
Just kidding. I just wanted to push the button. No homework for tomorrow other than finishing the objective. Khan Academy is due tonight. I was looking at scores. There are many of you that have not done any Khan yet, so you've got an ample amount of time to work on it here. You have a math packet out there as well. And that is it for today. Okay, that is it for today. Questions, comments, concerns, complaints, comments, congratulations, or criticism.
So this is our homework.
Yes, the binder pages, CO33 is your homework. Aiden,
Let's do.
thank you very much.
Ooh, where'd you get it?
Came with the sunglasses. Shinesty.com, which is why the glasses say Shinesty on them.
Oh, so they actually did come with the suit.
Yes, I wasn't lying.
Oh, I thought
It
you
was a free gift. Free
were. We're
gift.
with cops now.
All right, that's all I have for you.